Welcome to a lesson with Dr. Powell. Let's take a look at the graph of a hyperbola from an equation in standard form. Suppose, for instance, that we have something like negative x plus 1 quantity squared all over 16 plus y minus 2 quantity squared all over 4 is equal to 1. Now we know it's a hyperbola because notice that this sign is different than this sign here. Okay, now we look at the center. The center is at -1, comma 2. We get that from here. What makes this 0? What makes that 0? -1, 2. So we have our center at -1, comma 2. And we know it's going to be opening in the y direction because we have a positive here. Even though this length is longer, that doesn't matter for opening up and down. It's the one that's positive. Okay, so in this particular case, we're going to be going in the y direction up and down 2. In the x direction, we go to the left and right, double that. 4 and 4, something roughly like that. All right. Then we can draw a little box. So we draw diagonals through the corners of the box. Oh, see, like that. And then since we're opening up and down, because this part's positive, there's a graph. All right. Now, let's come up with what the equations are of the asymptotes. All right. The asymptotes are just transformations of y equals x and y equals -x. Okay, so now what transformations? The same ones that we had here. Now these transformations are determined by what's in the x box and what's in the y. So here we can rewrite our equation like this: x plus 1 over 4. Notice how I took a square root of 16 to put it in there. Plus, and then this would be y minus 2 over 2. So really, this replaces x, this replaces y. So we just do that here. So we have this replaced for y, so y minus 2 over 2 is going to be equal to, for the top equation, just say this is equal to that. Because this is like, quite literally, this is like y is equal to x. Then you do the same thing with a negative. And voila, we have the two equations of the asymptote lines. So we were able to draw the graph, and we wrote down equations of the asymptote lines right here. Now you might say, hey, well, can't we simplify that? Yes, we can. We can go ahead and do that. We can work through that process here briefly. So in doing that, we could, like in this one right here, we could multiply everything by 2 or 4 even, multiply both sides by 4. So you don't have fractions anymore. So then you would have, think about that, multiply by 4, then that cancels. So you get 2y, because this becomes a 2 and a 1, right? So then it's just 2 multiplied into 2y minus 4, this 4's cancel, is equal to x plus 1. So we could then solve for y, add 4 to both sides, so x plus 5, and then we can divide by 2, I guess. Again, see, y is equal to, but then we divide everything by 2. And so 2, sorry. I meant to write 2. All right. And there's the equation of one line. Now, the other one is the exact same process, it's the exact same equation, but with an extra negative. So imagine that we do the same thing where we have, let's start from this line. But imagine on this side, you're going to have a negative x and a minus 1, where you have a negative on that side. So then just do it again. So add 4 to both sides, but this time it's going to be a plus 3. And then if you divide by 2, you'll end up seeing you're going to get something like this. So we have the equations of our two asymptotes, and we have the graph drawn of the hyperbola. Thanks for watching.